Alright, let's take a look at elimination, the process. We'll talk about it. So we've got 6 steps here, and we've got an example. So once again, we're dealing with systems of equations. So 2 equations, right? So the first step here is to write the equations so that the same terms are aligned. So in other words, like this, the x's, plus or minuses, the y's, the equal sign, the other number, that it's all written in that top bottom order. Okay, this way, these 2 equations were already like this, but let's say you had x equals 14 plus y and x plus y equals 2. And you'd have to somehow either take this y to that side or take this y to that side of the equal sign to the left to get it lined up. Okay, so that's the first step, making sure they're all aligned. Okay, the second step is checking to see if you have coefficients of one variable that have the same number. Okay, in this case you've got positive 1 and positive 1, or positive 1 and negative 1. Okay, so you've got to make sure those are all, you have at least one of those variables that's set up that way. Okay, so the third one, once you've got that, add or subtract the equations to get one variable to become 0 and be eliminated. Okay, so if I look at this one, they've got that positive 1 and that negative 1. So if I add them, we're going to get rid of our y term. Okay, now I could also subtract, because the ones are exact, or the x's are exactly the same. You could also subtract and get rid of those. You would have went 1 minus 1 to get 0x. 1 minus a negative 1 would be a positive 2y. Equals 2 minus 14 would have been a negative 12. Okay, so this one, they eliminated the y variables, because 0 times y is 0. Okay, so once you do that and eliminate one of those variables, you solve for the remaining variable. Okay, so 2x equals 16, so they divided by 2 and got x equals 8. Okay, now once you have that answer, half your answer, you take that, plug it back into one of your equations, kind of just like substitution. They said, well, now we know this x is actually 8, so we put an 8 in there, subtracted 8, figured out the y was negative 6, and then they wrote down their solution as an ordered pair. Okay, if we would have done it by subtracting instead of adding, you would have just divided by 2 and got y equals negative 6. Then you could have taken one of your equations and plugged in the negative 6, and you would have ended up getting the positive 8 for x. Okay, so let's take a look at our first example, number 1. Okay, so now we just got some examples to follow through. So first step, they're all aligned. Okay, so we're good with that. Second step, let's check the coefficients. Well, the y, 7 and 2, they don't match up. The x is 3 and 3. 1 is negative, 1 is positive. That works. Okay, because 1 is negative, 1 is positive, we know we're going to add them, because our objective is to get those similar coefficients to equal 0. The only way I can get those to equal 0 is by adding them. Had it been a positive 3x and positive 3x, I would have subtracted. So if they have the same coefficient to the same positive or negative, you're going to subtract. If they're the same number but opposite signs, like 1 positive, 1 negative, you're going to add. So negative 3 plus 3 is 0x, plus 7 plus 2 is 9y. Negative 20 plus positive 29 is positive 9. That 0x becomes 0, so we can eliminate it. Hence it's called elimination. 9y equals 9. We solve for that. That was what? Step 4. Step 3 was right here. Step 4 now. So y equals positive 1. So now we pick one of our equations. It doesn't matter which one. So 3x plus 2 times 1 equals 29. So we just substitute in the y variable and we solve. Subtract 2 from both sides. That gives us 3x equals 27. Divide by 3. and x equals 9. So what's our point? The point where they intersect is 9, 1. Because remember, the whole point of this is we're finding out where these equations are the same. That's the whole point of using systems. Alright, let's just bust out some examples. So number 2 looks very similar to the last one. They're all lined up. I've got the same variable for x. They're opposites, so I'm going to add negative 9 and 9, give us 0x. 2 plus a negative 7, negative 5, y. 10 plus a 10 is 20, so I get negative 5y equals 20. Divide by negative 5, we get y equals negative 4. There's half our answer. Then pick one of my equations, doesn't matter which one. Plug in my y value, and then we can solve for the x. So that's negative 8. Negative 9x plus negative 8 equals 10. Add 8 to both sides. Negative 9x equals 18. Divide by negative 9. And x equals a negative 2. So my answer, negative 2, negative 4. That's where they intersect. Number 3, same idea. X's, y's, regular numbers lined up. A positive 2 and a negative 2, so I'm going to add them. And we can get rid of the y values as well, but right now it's set up so the x values are the ones that are easier to get rid of. So that'll be 0x, 10 plus a negative 3, positive 3y, negative 6 plus a 3, negative 3. So negative 3y equals negative 3, divided by 3. We get y equals negative 1. Now the thing you have to remember is you're going to have to watch the signs and what you're doing. If you need to, go, okay, 10 plus negative 7, type it in a calculator, and get the right thing. And pay attention to this. If it's positive, it'll be plus. Had this been a negative 10 plus a positive 7, it would have been a minus 3, and that would have changed things. You've got to pay attention to the positive or negative, because that could totally mess up your answer. Okay, you could still maybe possibly get this pretty close, but when you plug it in to another equation, it's going to totally screw that up. So you do have to pay attention to that. One small mistake on these systems, because there's so many steps, it can really mess up your answer. So then we solve for x, and we get x equals a positive 2. So my answer for this one, 2, negative 1. And that's all we do. We just keep going with it. Now if I look at number 4, this time the y values, the y variables are the ones that are the same. And notice they're exactly the same. They're both positive. They're both plus. So this time I'm going to have to subtract. So 5 minus 7, negative 2x. 3 minus 3, 0y. Negative 8 minus negative 16. So this is where it can be helpful to write it out, because I realize that that's going to be plus a positive 16. So negative 8 plus 16 gives us positive 8. Okay, so you got to be aware of that. So negative 2x equals 8, divided by negative 2, and x equals negative 4. Pick one of our equations and just plug in negative 4. We get negative 20 plus 3y equals negative 8. Add 20 to both sides. 3y equals positive 12. Divide by 3, and y equals positive 4. So our answer, negative 4, positive 4. That's where they intersect. If we were to graph them, that's where they're the same. So you can see, even though we got the different variable, still it's the same exact process. Okay, looking at number 5. The x's, y's, regular numbers are lined up. I've got the same coefficient for y, the exact same, so it's going to be subtract. So negative 5 minus 9, this is where it can get tricky, so if you need to, use a calculator. That's negative 14x. Negative 3 minus negative 3, that would be like adding them, so we get the 0y. If you don't get rid of both the y and the x variable, or at least one of them, I guess, you know you did something wrong. So if you added, maybe try subtracting, see if that helps. Now negative 3 minus a negative 3 again, same thing, that would be 0. So we get negative 14x equals 0, and that's fine to have, because when we divide, we get x equals 0, which is an alright number to have. So then, pick one of our other equations. Let's go down here. So 9, substitute 0 in there. Solve for y. So negative 3y equals negative 3. Divide by negative 3. We get y equals positive 1. So our answer, 0, 1. Okay, number 6. Positive 1x, so we got to subtract. So 1 minus 1 is 0x. 3 minus a negative 2. Remember that makes it positive, so that would be 5y. Positive 5y. Negative 22 minus 18 would be positive 40, or negative 40. Stays negative because we're adding or subtracting. So we get 5y equals negative 40. Divide by 5. Y equals negative 8. Then pick one of our equations. X minus 2 times negative 8 equals 18. Negative 2 times negative 8 is positive 16. Subtract 16 from both sides, and we get x equals positive 2. So our answer, 2, negative 8. That's where they intersect. Alright, now if we look at number 7 and 8, now we notice things aren't lined up, are they? Now it doesn't really matter how you line them up. You can always try to get them in that standard form, but you don't have to. So if I'm looking at this one, probably what I'm going to do is I'd add the 3y here. So I get 3y plus x equals 14 for my first equation. For my second, I would add the 3x, because that would give me negative 3y plus 3x equals negative 54. Now they're lined up. Now I've got the positive 3y, negative 3y, so we get to add. So that's 0y. X plus 3x is 4x. 14 plus negative 54 is positive negative 40. So 4x equals negative 40. So we divide by 4. X equals negative 10. Okay, now I can either use this version of the equation, I can use this version of the equation, doesn't matter. I'm going to use this one. So negative 3y equals negative 54 minus 3 times negative 10. So negative 3y equals negative 54 plus 30, which would be negative 24, divided by negative 3, and y would equal positive 8. So our answer, negative 10, positive 8. Okay, so number 8, same idea. The x's are on the same side, the y's are on the same side, so I would just add this 8. So we'd end up with 28 equals negative 10x plus 6y, and 8 equals 10x plus 6y. Now we're going to decide, do I go for 6's or do I go for the 10's? I'll do the 10 so I can add. It doesn't matter if you did 6's, you would subtract. 28, actually, let's do subtraction. I like that one better. 28 minus 8 would give us 20 equals negative 10 minus 10. Negative 20x, 6 minus 6, 0y. Got rid of that. Divide by negative 20. We get negative 1 equals x. Then we can pick one of our equations, doesn't matter which one or which version. I'll probably just pick the top. So 28 equals negative 10 times negative 1 plus 6y. Positive 10 plus 6y equals 28, subtract 10, 18 equals 6y, divide by 6, and 3 equals y. So our answer for this one, negative 1, 3. Alright, so that's the way we go. We just keep doing the same thing. So this one I've got my x's lined up, so I just need to rearrange those two, right? So I would just go negative 2x equals negative 10y minus 18. Now if we look at this, we don't have any numbers that match up, do we? Okay. However, do we have some numbers that could become other ones? Well, can I make a negative 2 a 30? Yeah, it times it by 15, right? Can I make it negative 10 30? Times it by 3. Okay, so we're going to have to increase by some number. Not increasing by adding or subtracting, we're going to multiply. And when we multiply, we have to multiply every piece in that equation or else it won't work. Okay, it was just like when we talked about the cat and dog food. And we were trying to match them up, and we had to end up doubling one of the cat foods to get it to be the same. Okay, same idea here. So if I look at this, I like to go with the smallest number, so I'm going to multiply by 3. Now I could multiply by -3 to get it to be a positive 30, but I don't have to. So I times each of these, just the bottom equation, I don't have to do it to the top. So 30x equals 30y minus 90. So 3 times -2 is -6x. So we're just tripling this whole thing. -10 times 3 is -30y. Now I got the same coefficients. And -18 times 3 is -3054. Now we can add 30 plus a -6, 24x. 30 plus a -30, 0y. -90 plus a -54 would be a -144. So 24x equals -144 divided by 24. I believe that'll give us a -6. Right? Because 24 times 6, 4, 2, 12, 1, yeah. Now, to plug in my -6 for x, I can use this equation, this one, or even this one. Any one of these versions I can use. Okay, it doesn't really matter which one. We'll use this one right here. So -2 times -6 equals -10y minus 18. So multiply those together, be positive 12. Add 18 to get the 10y by itself. So it would be 30 equals -10y divided by -10. You get y equals -3. So my answer, -6, -3. So a bit more work on this one, but it's the same process. So number 10, same idea. I've got to, first of all, rearrange, so I'll subtract a 6y. So -10 equals 2x minus 5y, just repeating that top equation. The bottom one we change, so it would be -14 equals 2x minus 6y. Now, we've got the same coefficient, so I don't have to multiply here. We're just going to subtract. So 2 minus 2 would give us 0x. Now, -10 minus 14. Write it out if you need to. Except minus 14 is really plus, so we're really getting a positive 4. -5 minus -6. That's really a plus, so our coefficient is actually going to be a positive 1y. So we get 4 equals y. Then we pick one of our equations. Okay, we'll take a look at maybe that one. So 6 times 4 minus 14 equals 2x. So 24 minus 14 equals 2x. That would be 10 divided by 2, and we get 5 equals x. So our answer, 5, 4. It's where they intersect. Alright, well there's all our examples. So remember, now we have 3 types of ways to solve a system. The first one is graphing. Very useful if they're in slope-intercept form. That's when I tend to use graphing. If it's not in slope-intercept form, I don't like to use it as much, though you can. The second one is substitution. This one I don't like as much, but I will use it if one equation is already solved for y or x, and it's easy to plug in. Okay. And this last one, elimination. Okay. Which this is the one I like probably the most. Okay. I think it's the best one to use in most situations. The only time I guess I choose graphing over elimination is when I'm able to easily graph. And substitution, that's kind of the one I prefer to use the least. But there we go, guys. There's 3 ways you can do it. Any of these problems can be solved using these three methods.